If you don't have a handout, there's 3 handouts over there, cheat sheets. You should grab a copy of each of those. We have not very many people here yet, but we're going to go ahead and get started. That the Friday classes are supposed to start right at 11, not the 11:10 after 10 minutes start time. So we'll get started, and things are not showing up. So let's make them show up. Okay, let's make this a little bit bigger too. How's the Docker Compose Flask on Docker thing going? Okay. A lot of work? Not a lot of work? Good amount of work? Perfect amount? Okay. I don't know, does anybody, I know a couple people had specific technical questions about your things that you were running into, but anybody have any general questions or any questions that you want to ask right now? So?
I'm just wondering, is there a case where Docker is OQ for like small project or like any size of project to be using Docker?
Oh yeah, so questions sort of like the size of the project. And I'm gonna, so right over here, I have the week 2 notes, and there's just 2 little spots that I sort of skipped over before that I'm gonna revisit now, talking about exactly the size, appropriate size of a project for Docker. And so I mentioned there's this idea of vertical scaling and horizontal scaling. So vertical scaling being getting your system more powerful, making it scaling that way, more powerful system. Horizontal scaling, making it adding more machines, more powerful that way. And the horizontal scaling is the thing that Docker is really good for. And if you're not doing anything with, say, more than like terabytes of data, then you don't need the sort of Docker systems. There are maybe software engineering reasons to use it beforehand, but after like the terabyte sort of scale, you definitely 100% need Docker. And Docker is also going to take you like sort of pretty much all the way into like arbitrary scaling land. There's this little comic right here that we have. So there's Docker, Docker Compose. We're learning these 2 sort of technologies. There's this other thing called Docker Swarm. Docker Swarm is like Docker Compose, but really for if you have, say, maybe 100 to 1,000 different services defined in your Docker Compose file, and you have like little evil goblins that are going around with axes smashing your servers, and you need some system to automatically start your servers after they fail. So that's what Docker Swarm is for. And then Kubernetes is like Google's version of Docker Swarm. Still uses Docker under the hood. And, but if you need like millions, hundreds of millions of machines running distributed all around the world, that's what Kubernetes is for. Right?
So Docker is for one application. You want to make sure the code is stable forever. So you have one container for many where you don't have to change through the dependencies. And then is Docker Compose just like the next level of that, where you're like scaling that?
Docker Compose is basically automating Docker. So you don't have to do all those manual commands. You just run Docker Compose up, and it brings up everything for you. Yeah. And then, yeah. And then if you had 1,000 machines, there would be some annoying things with Docker Compose. Docker Swarm automates Docker Compose. Kubernetes automates Docker Swarm. Good questions. Any other sort of big picture questions or any questions at all? Okay. One maybe last technical thing to point out. Just a reminder that's on this homework, very important that you don't give me any of the credentials to your database, your production system in any way. And that if you do, it's -2 points, but not like whatever you get -2 points. It's actually -2 points. It's better to turn in nothing than to turn in a correct system with your passwords inside there. Because if you were like at a company working at a bank, say, and you uploaded your passwords to GitHub, then random hackers from the internet will take all the money out of the bank. And that has happened many, many times, costing companies billions of dollars, like with a B, billions of dollars. And you don't want to be the person who does that to your company. So you should be legitimately scared anytime you're like touching a file that contains a password in it. I personally feel like fear anytime I touch those files. This .gitignore file is something that you can use to protect yourself a little bit. So I'm going to switch over to the terminals for a second. Over here, I'm in the Flask on Docker, ls. So it's a completed version, and it has this .env.prod.db file. Go ahead and open that up. This is the file. This in particular is the thing that you want to protect right here, so that I can't have access to it. If I can get access to this thing in any way, then negative points on the assignment. And one of the easiest ways to prevent that, this .gitignore, vim.gitignore, is to just put that particular file in the gitignore, and then Git will prevent you from adding that into your Git repo, and so it won't get uploaded. There are, I also have these lines right here, start out swap, swo, swin, swim. These are the names of the extensions on the files that Vim creates for your, when you open up Vim. So if I do, when I do vim.env.prod.db like this, and then down here, let's go back into the Flask on Docker, and let's make it big so we can all see it. And then if I do ls-a, not only is there this .env.prod.db, there's this .env.prod.db.swap. It's also something that we don't want to have added because that's going to contain the password information inside of there, just in sort of a obscured format. And so the those other lines in the gitignore file make sure that these swap files don't get added. Any questions about passwords, gitignore, anything else, Tom?
So, I haven't had the swap file and the other line gitignore, and if I update it right now and then push to my repo, will it update?
Oh, that's a great question. So what happens if we accidentally add something that we don't want to add, then put something in gitignore? Will it retroactively take that away? And the answer is no. That, it is possible to remove something from a Git repository. It's extremely difficult to do, but it is possible. But even that is not enough, that there are bots that are scanning everything that gets uploaded to GitHub, like the millisecond that it gets uploaded. And so if a password is ever up there, even for like a fraction of a second, you need to assume that that password has been compromised and immediately change your credentials. GitHub has just recently, like within the past year, added a bunch of security checks where they try to check if you've uploaded different passwords. Something like these environment files, they can't check because this is not a standard format. But if it's like credentials to AWS or a lot of bank account credentials, those ones they can check and will stop you from doing that. even if something's in the git ignore file, so let's see, down here if I did git add dot git ignore git status, you see it doesn't actually add anything. If I added the -f flag, then it actually, oh, maybe, oh, git ignore is not what I wanted to add. This file right here, that's the file in the git ignore file, git add.env.prod.db. Then it'll give us this warning saying, hey, you shouldn't do this, but if you really want to do it, you can add this -f flag. If I were to do that, then I could actually add this and push it up. So the -f for force, always a dangerous thing to do. Probably don't ever want to do it on any of the commands that you're running. All great questions. Let's see, those of you who just came in recently, if you didn't notice, there were some handouts over there on the far end of the, yes, right there. So there's 3 of them, cheat sheets for things that we'll be starting today, so make sure you get a copy. And any other questions about lab homework? Okay. So today we're going to be, we finished up everything that we need to talk about with Docker and Docker Compose and all of this sort of background information. And today we're starting in on SQL in this Postgres database. And in the GitHub repository, even though we're sort of technically in week 2 of the semester, I've put this in the week 3 folder because, again, we're moving at a slightly faster pace, having these extra Friday sessions so that we can get a little bit ahead of where we would normally be during the semester, so that when my wife has our baby, we won't miss any material. And so this is like we're starting the week 3 proper material today during week 2. So that's why this is under the week 3 folder. And we're starting basic SQL. So this week 3 weirdness, we're now ahead of schedule, which is where we want it to be. There is a homework posted under this week 3 folder, this Pagilla-homework repository. We're going to be starting going over that in class today. So I'd recommend cloning that repo and making sure that you can bring up the Docker container that's inside of it. And it'll be like maybe 10 or 15 minutes before we get there, but try to have yourself ready for when we do. And so all your grades update in Sakai. Current median grade is an 89% in the class. The quiz scores were, so here's the graph of the quiz scores. If you were particularly disappointed in your quiz score, so say less than getting a 9, then I'll give you the option of retaking the quiz sometime in the next week. Just come to my office during office hours, or right after class is fine too. I'll give you a different copy of the quiz. You can try again, and whatever score you get, up to 9, will be what goes into Sakai. Any questions about that? Yeah. No.
So it can be up like more than 9.
Correct. So if you got a 12 out of 12 on the quiz, then you would just get a 9 entered into Sakai. So if you, on the quiz, the actual quiz got a 9 or higher, then no benefit to retaking it. In general, my grading philosophy in this class is that I don't want somebody to be punished if you just had a bad day or something like that, and that I think your grade should reflect your knowledge at the end of the semester. And so there's a chance for you to demonstrate your knowledge that you maybe were not able to demonstrate on the quiz itself. Not going to guarantee that I'll do things like this on all of the future assessments, but possibly. Another announcement, so TA update. I realize it's very frustrating that I haven't been able to, so I have two TAs picked out for this class, and there's still a whole bunch of administrative hurdles, bureaucratic things that are blocking them from being able to properly be TAs for this class, which is frustrating for everybody. I know TAs are super helpful for a number of reasons. They have more available times, especially in the evening, than I do. And sometimes it's just better to get a former student's explanation of things. So I'm doing my best to get that resolved, but it's not resolved, and I apologize. So one of the students hacked my account. Good job, Joey. You should always be trying to break things in this class, and anytime you break something for any reason, if it's a cool thing that you've done, you'll get extra credit. You won't get in trouble. This also brings up this link right here, which I wanted to add and remind you of all that we have this caveat task of different reading and or viewing that you have to do in this class. And this article right here can count towards that if you want to look at it. But this is an extremely recent security flaw that was found in the Linux kernel and how it interacts with Docker. Some features of the Linux kernel that were added to make Docker work. And this vulnerability was found just about a week ago and results in what's called privilege elevation or privilege escalation, and it would allow any user account to get root access on the Lambda server. The Lambda server turns out not to be vulnerable. It has an older version of the Linux kernel, so you can't actually do this to take over the Lambda server. But if you think you have a way of taking over the Lambda server, please attempt it and try it. And if you do, you'll get extra credit in the class. Okay, last thing today. So we're going to be starting SQL again, but we won't be getting too technical today. But Monday, we were really going to be doing SQL in earnest. And so you should try to make sure that you are really comfortable with some of the basic SQL that was expected to be prior knowledge from like the Foundations of Data Science class by Monday. And in particular, you want to make sure that you're comfortable with the idea of a SQL join for Monday. Got some references down here that you can review to make sure that you are comfortable with that. Down here, there's, this sort of week, we're going to be going over the select and the join statements. You'll need to know the select and the join statements inside and out for your homework assignment that will be due at the end of next week. And so just reviewing this PostgreSQL tutorial.com, this is sort of like our textbook for this section of the class. We're going to be going over sections 1, 2, 3, and 4 here. And my experience is that most students are fairly weak on understanding joins in SQL, and we're going to be going over this material fast, so it'll be good to review this before Monday. Any questions about that? Okay. Everybody seems kind of dead today. Is that morning? Announcements are just boring. We need technical stuff. Bash, SQL, Docker, that'll wake us up. Okay, thumbs up, okay. Bash is my caffeine. Any questions before we get started on talking about SQL? Yes, Kieran. Fantastic question, I know what you're gonna ask. Okay, let's go to our, if I don't know what I'm gonna ask, then correct me when I'm done, but we need to do this next anyways. I'm gonna open up my terminal windows down here. I'm gonna go to the project folder, cd ... And let's see, I've got a lot of things in here. Here's the Pagilla-homework repo. I'm gonna go ahead and delete that -arm-rf, Pagilla-homework. And then let's git clone, https://github.com/mikeisvicky/Pagilla-homework, and hit enter. And it's going to recreate that folder for me right here, and let's go inside of it, cd Pagilla-homework ls. And now I'm going to, there's a Docker file in here and this Docker Compose. I'm going to use Docker Compose to try to bring up my database by running Docker Compose. And the first thing I'm going to do before running my database is building my database. And actually, before I hit enter there, can people see the bottom part of the screen? That's okay. Yep. Question is, do we fork it? And the answer is that at this point in class, you don't need to. You just need to be able to get access to this on the Lambda server somehow. But for the homework assignment, you will need your own separate fork so that you can push something to that and submit the fork. So yeah, probably good to just go ahead and fork it and clone the forked version now. But when I press this build button, hit enter down here, then we get this error message down here saying the different SQL files don't exist. And that's not, I don't want to say that's intentional behavior, but that is expected based on the commands that I've run so far. There's been no errors. And so in order to explain what's going on, we're going to, up here in GitHub, take a look at the Pagilla homework folder. So click right here, Pagilla homework. And before I do that, let's recall that on the GitHub interface, anytime you see this @ symbol and then a hash over here, this is in Git terminology, a submodule. So this Pagilla homework is not a folder inside of our class repo right here. This is a totally separate Git repository. And I've clicked on that. And inside here, you can see there's another submodule inside of Pagilla homework called Pagilla. These right here are normal folders. And so when I clone this repo, I get all of the contents of these folders. But this right here is not a normal folder, it's a submodule. And so when I clone this repo, I do not get the contents of this submodule. Back over to the terminal, ls. We can see here's those 3 folders. If I type something like ls SQL, there's a bunch of contents in this folder right here. But if I type ls Pagilla, there's nothing in that folder because it's a submodule and git clone does not download submodules. Back over to GitHub. Let's take a look at what the contents of this submodule. So this Pagilla repo is not something that I've created. It's not something that's specific for this class. This is a generic repository, generic database for Postgres. And a lot of tutorials, a lot of documentation use this. And so that's why this homework assignment is based around this sort of standard repository. But we have to get that repository. And so down here are the commands to remind us of how we can get submodules in Git. We want to do the, so you clone it, we've done that. Go inside the folder, we've done that. And then it's the git submodule init, git submodule update commands. Git submodule init, git submodule update. And now it's downloaded it. Now if I typed ls Pagilla, we can see there's a whole bunch of stuff in there. And now if I run the Docker compose build, that will, it has the files available now, so it's actually able to build things. Did I correctly predict, Kieran, what you were asking? Awesome. Any questions about any of that? Okay. So he's got some modules. They're a little bit of a pain to work with, but incredibly widely used. Basically, if you're working at Facebook or Google, you don't want to have like one repository that has the entire code base of your company inside of it, because the entire code base is going to be multiple gigabytes and potentially even terabytes. And so that's going to just make things awkward and slow. And these Git submodules allow us to branch things off, allow people to really focus down on just one part of a project at once. And so that's why the homework in the class is structured this way. Okay. Let's see, since I have the Pagilla homework page. Oh, yes. Right. The Lambda server should be up just fine. I'm currently logged into the Lambda server, and yeah, so I have access. So no route to host, that's a networking problem. That means that somehow the computer is not able to connect yet to the server. Yeah, I don't know, that'll be a potentially hard thing to debug. So I'll have to look at that maybe one-on-one after class. Good question. Any other questions so far? Yes. How did the name Pagillo, where does it come from? So the purpose of this repository, or the idea of it, the idea of this test database, is that it's like a, so it's created back in the days when like Blockbuster was the cool thing. So like, I don't know, 20 years ago or so. And so this is like a database that you would use to run a company like Blockbuster, renting out DVDs to customers with thousands of franchises spread out over the world. This database was originally created for a program called MySQL, a database system called MySQL. And the person who created that called this fake company Sql. When they ported it over to Postgres, they changed the first letters over to P for Postgres. So now that's why it's Pagilla instead of Sql. Okay, so yeah, I have the README file opened right here, and you can see that there's this little badge that we've seen from the very first homework in this class. And basically in this homework assignment, you're gonna have to complete a bunch of SQL problems until this badge turns from failing to passing. And we're gonna be talking about how to do that throughout the next couple days in class. But a high level overview is here is the, this folder has 17 problems inside of it. Each problem's worth 1 point. Each problem has some description up here about what you have to do in SQL, and then over here under the expected, there's what the output is supposed to look like, and if your command matches this output, then you get credit and you pass it. You implement all these problems, passing them all, and then your badge will turn green.
Mike?
Yes.
So is this like a SQL implementation of PyTest, or is this just...
Great question. So yeah, questions, how does this relate to PyTest or other testing frameworks? We'll talk about that in more detail once we've just seen some more basic stuff, but the entire framework that we're using here is like actual production SQL testing stuff, just like PyTest is an actual production testing framework for Python. So this idea of having a folder SQL with different SQL commands, this expected with the output is the standard way of, in Postgres, if you have a library or something with SQL code, of standard way of providing test cases. Good question. Any other questions so far? Okay, so then let's head back to that's what I need, the back button. And back button, head back to the week 2 folder. We made it, week 3 folder. And there's a bunch of little intro stuff here at the top, but my sense is that that's gonna bore us all right now, so we're gonna jump straight into some how to actually use the system, and then revisit this next week. So I have my 2 terminal windows open here, and I want them both to be in this Pagilla homework folder. And now that I've successfully ran the Docker Compose build, I'm going to run the Docker Compose up, and we'll do up-d, send it into the background. And let's do a Docker PS, whoops, Docker PS to see all the Docker containers that are running. There's a lot of them running because I have some open from the last classes. So I'm gonna just go ahead and kill all of these Docker containers at once. Easy way to do that using our cool POSIX shell skills is if I do docker ps-q, Q stands for quiet, so it gives me only the lists of the hashes of the containers. And we have the docker stop command. And I know that the $ with the parentheses, this is going to run whatever command I type next after it. And then it will pass that as a parameter to the docker stop, like this. Hit enter. Now if I run docker ps, all those things are gone. And anytime I stop things, I probably want to remove them as well, because if I did say like docker ps-a, there's a whole bunch of stuff still there. So I want to, if I do docker ps-qa, QA, that will list the hashes of the things so that I can successfully pass them to the docker rm command, docker rm. There we go. There's the list of hashes. Now they're all dead. And docker ps-a, nothing's around. So I've cleaned up my Docker environment a little bit. Let's rerun docker compose up-d, this one container. So we'll just have one container running now. And docker ps, there it is. When I'm using docker compose, I need to know the name of my service. So let's real quick vim docker compose YAML. I tend to call my database servers PG for Postgres, very common abbreviation for this database. And so docker compose up, not up, exec. I want to run a command on PG bash. And now I'm inside of the container connecting to this, connecting bash in this container. The particular command, yes, Joey.
I'm just curious, can you go over what the Q flag was doing?
Sure, yes. Question is, what exactly was the Q flag doing in the docker ps command? By default, docker ps has what we would say is human readable output because it has this nice little table here. My screen's not big enough at this font size, but if I lower my font size, then everything's formatted nicely, and it's easy for a human to look at this and say, okay, here's the container ID over here, here's whatever the command's running, here's how long it's been up. But sometimes I don't want all that information. Sometimes I want a machine readable version of the output, and -q stands for quiet. Q equals quiet. And so it's a common flag for giving us machine readable things that I might want to pass to another command. Docker ps, I would never want to pass this output to another command, but this output, nice and succinct, easy for another process to process it. And so this right here is the container ID of the machine that was running. And I could type docker stop like this and then paste the container ID. Or since I had a bunch of them before, what I was doing was just manually automating that process, docker ps-q. This right here, outputting all of the container IDs, passing that to docker stop, which stops all of the container IDs. And then when I wanted all the container IDs, including the hidden ones, I added the A, because the A gets the hidden ones as well. Good question. Any other questions right now? Okay, I want to get back up to my, let's make this a little bit bigger again. I want to get back up to my command that brought me inside of the Docker container, but I am lazy. I don't want to type it out again. And I'm so lazy, I don't even want to hit the up arrow because I don't know how many times I have to do that. So instead, I'm going to type Control R down here in the terminal so that I can search. And I know that command had the word bash in it, so I just type the letters BAS. And then I get this command back up and hit enter. Notice that I don't even have to move my cursor to the end of the line. Doesn't matter where in the line my cursor is. I hit enter and it runs it. I'm now in the Docker container down here and connected to the machine that has the database on it, but not directly connected to the database yet. The command that connects you to the database is called pSQL. P standing for Postgres, SQL standing for SQL. And I hit enter, and now I'm connected inside of Postgres. I know that I'm connected to the database because my prompt over here has, it's different now. It's not ending in the $sign. It's not all this green stuff. It's not the greater than signs from Python. It's Postgres equals hash. And now whatever I type in here is a Postgres command. Any questions about that? Yes.
Is that like by configuration that whatever you type down,
Like why does this not say root? This is a really good question about how exactly does the prompt, like what does the prompt mean on pSQL? And so up here, if I type, for example, who am I am root. But when I go into pSQL, the database has its own, it does have a permission system. It has a very complicated permission system, but the permission system is totally separated out, totally different from the Unix operating system permission system. And so this right here is actually just telling me the name of the database that I'm connected to right now, which just happens to be Postgres. People do a lot of customizations on like their bash prompts and terminals. I've never really seen people do a lot of customizations on their like pSQL terminals. Yeah, so I don't even know like what all we could do or how we would even go about setting this. But the main thing is just to be able to recognize that we are no longer in bash and inside of Postgres. I don't know, did that answer your question? Maybe real quick question. How many people, has anybody here ever used Postgres before? Okay, for live, yep. And then a handful of other people. What about people here used SQLite? More hands. Either MySQL or MariaDB? More hands, okay. Most of the stuff is the same between all these different database systems. Highlight a couple of the differences as we go along, seeing sort of the edge cases and why they're different. But anything that's well, yeah. So we're going to start with something that is not actually a SQL command. It's a pSQL command, and so this is something unique just to Postgres, not to any of those other database systems. And that's the \D command. And what this does is it lists all of the tables that you have in your database. The tables are sort of the fundamental unit of where information is stored. And we'll be talking in excruciating detail later in this class about how the data is physically stored and how to take advantage of that to make your different commands faster. But basically every one of these tables is like an Excel spreadsheet and contains different information. So \D lists all of the different tables that you have. It also lists some other things called sequences and views, but tables are sort of the most important thing. That's the fundamental thing inside of SQL. And then if we do \D and then the name of a table, like actor, it gives us a little rundown right here of what the contents, sort of like what the fields in that table are. It's technically called the schema of the table. So these list of columns over here is like the different columns in your Excel spreadsheet, and then what types of values that it can have, and various other properties. This stuff down here, indexes, referenced by, triggers, we'll be getting to that later in the class, but at this point, you can just totally ignore it, and the only things that we need are this information up here. This \D command is not on that Postgres cheat sheet that you have, but it is going to be super useful while you're working on the homework. So I would recommend, I think one of the pages has like a blank back. That's one of the things that I would recommend putting on the on that back page so that you can remember it. That \D gives you all of the tables, and \D actor gives you, or \D then a specific table gives you the schema of that particular table. So one last thing related to the schema. The most sort of fundamental command in SQL is the select command. select. And the simplest version of this command is select star from the name of a table. So select star from actor. And in SQL, every command must end in a semicolon. So this is sort of the simplest possible SQL command right here. The very first word, again, is the name of the command that we're using. And then this from is also a particular part of the command. This actor is the name of the table that we're looking at. So I'll hit enter, and it actually outputs in table format all of the different things inside of this table. And so here are all of the actors that are in the movies that are being sold in this, this fake Blockbuster store. And all this data is fake. I don't think Penelope Guinness is a real person. But there it is. Any questions so far? Yes.
So the Postgres equals dash, or excuse me,
The backslash.
Yeah. Is that like a separate shell for Postgres? The one that you're in right now, the PSQL?
Yeah, so this pSQL is technically a shell or terminal environment. The dialect that it speaks, though, is not the POSIX shell. It is the Postgres shell. The \D is a command specific to the Postgres shell. It's the only place anywhere in anything that supports this command. There are many other ways that you can connect to the Postgres database. We'll see later, and I think in the lab homework due this week, they show some like example Python code of connecting to a Postgres database that you just copy and paste. But if you're in Python, you can't do this like \D thing. You can do normal SQL commands like this, but not these things. And you know something is a special pSQL command because it has the backslash in front of it. Does that answer your question? Good question. Any other questions so far? Okay. So one of the hard things about a database is just like getting a sense of what is the contents of the database, what can you do with the database. And a good way to get that sense is here is a diagram that looks something like this. So in this diagram, each one of these boxes is one of the tables that we have in the database, and each one of these rows in the box is one of the columns of the database. And so here we have the actor table that we were just looking at, has actor ID, first name, last update. And then back down here, do that. We have the actor ID, first name, last update. So this picture up here tells us about the schema of the database. And these lines sort of tell us how the different tables relate to each other. What's going to be sort of the trickiest part of your homework assignment is that I'm going to ask a question like, how many movies were rented with a particular actor name inside of it? And so the actor table right here doesn't contain information about how many movies were rented. It only contains information about like what are the different names of the actors. And you'll have to go up to these other tables to figure out which tables have the information that you need. And then we'll be using the SQL join commands to connect those different tables together. I don't want to get into the details of the SQL join command today. We'll do that on Monday. But that's the idea. That's going to be the main trick of all of these assignments. And again, you'll want to try to review the join, get as much understanding of it as you can for Monday so that you're prepared to tackle these sorts of problems. For the rest of today, what I want us to do is just see some variations on this select statement by itself without the join, and that'll maybe see some of the weird things about SQL. So the first thing is that SQL is, well, maybe even before the first thing, let's say how to do comments. This is a comment in SQL. The double dash is how you make a comment. You can also make comments with this /*. This is a comment. And the /* is particularly useful for multi-line comments because you end the comment with the //. Those of you who've programmed in C or C++ before, this is just stolen from C. And this comment notation is sort of unique to SQL. Nobody else really does this. But this is a one-line comment equivalent of the hashtag in like Python or the shell. So now one of the really weird things about SQL is that SQL is case insensitive. And this is different than basically every other programming language. So up here I did select star from actor. I could also do select star from actor like that, and it gives me the exact same results. So case means nothing in SQL. And that's true both for, so select and from are what are called reserved words. Those are part of the actual SQL language. Actor over here is sort of like a variable because it's the name of a table. And it doesn't matter though, like you can't have a name of a table in SQL that is case sensitive. It's either, yeah, it's just lowercase, that's how it is. Or yeah, any case. The common convention, or a common convention, that makes SQL a little bit easier to read is to have the reserved words like select and from be in uppercase, and all of the things that a user has defined be in lowercase. Sometimes in this class, I will do things like this, especially if I have a prepared example that I'm that we're taking a look at. But sometimes I also just do everything in lowercase because my pinky gets tired and I'm not very good at using the caps lock key. And this is just easier to type. But no difference at all between any of those things. The star in SQL means something different than it does in Bash. It's still, yeah, so in general, the star somehow usually means like do everything. But in this case, it means do everything in a different way than it does in Bash. And it particularly means, right here is a list of columns that we're trying to get access to. So again, if I do \D actor, I can find out the names of all the columns. Here are the names of all the columns. And if I only wanted the first name of the actors, I could do something like select first name from actor like that. And now it only gives me the first name column and not all of the columns. Star means all of the columns. First name, not all of the columns. Inside of this pSQL terminal, I can use all of the cool shortcuts that you can use in the normal Bash shell, like the up and down arrows. I can also press Control-R to do a reverse search of what I want to get. So let's type select all caps. And now I have my select star from actor all caps right here. In general, it's really bad practice to use the star. And you always want to list out the particular columns you need. So what did I do? Bad practice to use star, list out all columns. There's a number of reasons for this. We will both stylistically and bug-wise and performance-wise. We'll see all of those when we get to the appropriate parts in the class. But it's never, in this class, there will be never a time when you want to do select star. You'll always want to have it select and then a particular column. Or you can do multiple columns separated by commas. First name, comma, last name gives you both those columns. Yes, Drew.
Can you index, can you use the indexes of columns like in the pandas? Instead of having to type out all the column names, or like do like a range.
So you're saying something like, so by index you mean like the square bracket sort of thing,
Yeah.
like 0 to 1.
Exactly.
You can reference columns by their ID in certain situations. Right here in the select statement, though, you actually can't. That if I were to say do something like select 0 from actor, it's actually literally gives me the number 0. We'll see why that's you want that behavior in the future, but you should also, whenever you're working with SQL, you should never sort of like count on the order of these columns being the same from one computer to another. So star, one of the reasons why star is bad is because star gives you the order of the columns as they are actually listed in the table right here. But there are good reasons why you might want to change the order of these columns, which we'll talk about in about a month. And yeah, so you never want to be like relying on the order of things. Always use the names. Great questions. Any other questions? Tone.
Is there a way that we can say that we don't want a column that we want every column except like last name, or like something so we have like many columns that we want to get, and then out there doing wrong? Is there a way like we can say like we don't want a specific column?
You always have to list things manually. Yeah. Okay, so now we're gonna start seeing some weird things. This is maybe like all familiar to SQL things that you've seen before. Now we're gonna get into the weird stuff that is probably something that most of you haven't seen before. So what if I want to like first name and like actually combine these two columns into one column? First name underscore last name from actor, semicolon. So here we get it as two separate columns, but what if I wanted this just as a single column? And actually, maybe before I do that, since I just accidentally went onto 2 lines right here, you'll notice that, again, SQL doesn't matter, like last name, white space doesn't matter. All that, you can do whatever you want, and then the command ends when you hit semicolon, and SQL just sort of morphs that all into one line. So white space does not matter in SQL like it does in Python. But here with this command, what if I wanted to combine first name and last name together? The way you concatenate strings in SQL is with the double bar like this. So that's weird. I don't know if, I have no idea why they chose that. It is not the plus, it is the double bar, and that puts 2 strings together. Here we can see that like it literally concatenates those. If we wanted to add a space between them, space like that, and now it puts the space between them. This, yeah, so why? So I don't know why they chose the double bar, but I do know why they did not choose the plus. The reason is because SQL was invented in the 70s. Back in the 70s, they didn't know how to design good programming languages where you could have one operator apply on different types of things. And so because the plus operator, you definitely wanted that to be able to add numbers together. They had to pick a different operator for adding strings together, and they chose the double bar. So this gives us our information as a single column like this. And up here, you'll notice that the column is kind of has an ugly title, question mark, column, question mark. It doesn't know what to call it because this is sort of a computed column. If you want to name a column, there's a special keyword called as. So as, and then whatever you want the name to be. So we'll do actor name like that. And now up here at the top, it says actor name, and that's all nice. Next thing that's weird about SQL is quotation marks. So if you thought quotation marks were weird in Bash, they're even weirder in SQL. The single quotation mark means like a literal string. So this right here is a literal string. Double quotation marks do not. This would give you an error message. Anything in double quotation marks refers to either a column name or a table name. And so up here, if we have something like this, I could put the actor in double quotation marks like that, and everything works exactly the same. Single quotation marks create literal strings. Double quotation marks create create column names or table names. The reason why you might want to surround something in double quotation marks is if you have a space in it. So like actor name space like that. Maybe you're very picky about your column names and don't like underscores, you can do that. But this must be in double quotation marks because it's referring to a column. If we had that in single quotation marks, then we would get an error message because this is a string literal. You can't do that. So that's not the weird part, though. That's not the weird thing about quotation marks in SQL. The weird thing is that the $ is a quotation mark. And so let's go here. I can, like this, two $ next to each other, this and this, those form a quotation mark. So this is putting a space right in the middle, like that. Same exact thing as that we had before. So let's move my cursor over here, like example. So it gives their first name, example, then their last name. So that's weird thing. People actually use these double quotation marks all the time in SQL, and the reason for that is because it's very common to have strings that have something like contractions in them, like isn't. And now that's how you put single quotation marks inside of a string in SQL. You can also, there's actually an infinite number of quotation marks in the SQL language that between the two $, you can do something like example. Sorry, my terminal is messed up. Let's reset it. Example, and let's paste that there. Semicolon, there we go. Run it. Okay, that runs, and example, that runs. Doesn't matter what goes inside these $. The purpose of this is so that you can, if you need $, like a double $, inside of your string, you can do something like this. And now those double $, are actually contained inside of the string. The $ example denotes the end and the beginning of the string. And we get the double $, like this. So it's very, very weird. And again, it's weird because it was invented in the 70s. This was sort of like random person, never seen a programming language before, decided that this would be a good idea. Nobody thinks it's a good idea anymore, but we're stuck with it to be backwards compatible. Any questions about, yeah, Joey?
Wait, so is it important that you have the same word in between the $?
Yeah, it has to be the same word over here so that it knows, like, it sees $, and then it says, okay, whatever comes next is the name of my quotation mark. $, is the end of the quotation mark. And then it knows that the quotation mark is ended because it sees example between these two quotation marks. It knows that these are not quotation marks because it doesn't have example inside of it. If I had something like examp, then there's no ul at the end, and so it won't count as a quotation mark. Yeah, so super confusing, but that's the way it is. Any questions? Yes.
Also, just out of curiosity, how are you going back like word by word in the terminal?
If you hold down the control key while you, so press the up arrow right now to go back to a previous command, hold down the control key with left and right, and it goes you left and right one word at a time. It's actually possible in all of these terminal systems to use vim key bindings actually in bash or in pSQL to edit the different things. I don't know anybody who does that though. Sometimes though, if I have a really long command like this, I I want to go back and edit it, and it's like, I don't know, the terminal is not a very nice way to edit a really long string. If I type \E, E stands for editor, then it will open up my editor and let me edit the command. My editor is Vim, and so that's what it opens up. Basically, the only options of what it could open up are either Vim or Emacs, because this is inside of a terminal, so it must be a terminal editor, and it's inside of a terminal that's inside of a container that's on the Lambda server, and so there's no way, like even theoretically possible, for something like VS Code to connect and do this. Something like this can only be done with a terminal system like Vim or Emacs. And then now I can edit my really long command like this, and starting next time we'll be seeing maybe like 5 to 10 line long commands, and definitely by like a month from now we'll be having like 40, 50 line long super commands that you'll need to be using an editor like Vim to try to go through and edit it. It'd be impossible to do on the command line. Let's see. I think that's technically, class goes to 12:05. I think that's a pretty good stopping place for us today, though. Next thing that we'll be talking about is the joins. And again, try to make sure that you have reviewed those for Monday, because my experience is that students feel very overwhelmed when we first start talking about those joins and figuring out what's going on. If anybody has other questions, I'll stick around and answer those. But otherwise, have a good weekend. Good luck on your homework, and I'll see you on Monday.